Broadcasting live from our studio in Boston, Solutions Review is proud to showcase Broadcom in the Solution Spotlight, a unique online event for industry professionals.
I'm Doug Atkinson here at Solutions Review, and welcome to the Solution Spotlight featuring Broadcom and focused on network observability best practices from site to multi-cloud. In a recent study by Enterprise Management Associates, the top two monitoring initiatives that are driving organizational priorities are public cloud and SaaS app adoption. Often labeled as app or service migrations, these include fundamental network transformations that reduce visibility into business-critical networks and services, which is why today we'll take a longer look at network observability and new techniques like active monitoring that can be added to the network operations toolset in order to understand the root cause of issues that impact end-user experience. And to walk us through the Broadcom solution today is Alec Pinkham, Product Marketing for AppNeta. Alec, thanks for being with us.
Thanks for having me, Doug.
Well, I don't think you could have come at a better time because just before we went live, for everybody watching live, if you're watching the on-demand, it'll all be cleaned up. But for the live feed right now, we started experiencing just before we went live all kinds of bandwidth and streaming issues, which you're probably experiencing if you're watching us live. And this is exactly why folks need Broadcom. So I should probably get out of the way and let you get to it. But if you want to use us as a case study, by all means, feel free.
Yeah, when I think about internet issues, everyone's been on this call where you have a few people that you can't hear audio or you can't see video. And it's always something that is, or almost always, something that's out of your control, right? It's the ISP, it's an external, party. For those of us who work from home, it could be our home Wi-Fi, but generally we've figured that out, right? We've solved a lot of those problems. So I would say self-serving to see it happen today, but I know we'll be able to figure it out. So I appreciate it.
I'm watching it kind of like desperately trying to render well, but I'm not optimistic. But that's okay, because I couldn't be happier, actually, that it's happening right now with you, because this is exactly what we should be talking about. And I'm going to let you get after it. But hopefully we'll be able to come back after your presentation and do a Q&A. But I'm going to pay close attention because of the local nature of this solution.
Thanks, Doug. So excited, to share some of the best practices for network observability from the Broadcom perspective. I specifically called out site to multi-cloud here as kind of two opposite ends of what I would call the sphere of responsibility when it comes to network operations, right? Our traditional network, our offices, data centers, maybe branch offices or smaller locations, and now the cloud networks, right? That we don't own, we don't typically have insight into, but often have to troubleshoot, or it becomes network operations responsibility to deal with when issues go wrong. And so let me start with the shift that's kind of happening in our world for network operations, right? There are new challenges that are emerging, right? The top here, when asked what the top challenges were for network operations, is a shortage of skilled personnel. And by a wide margin, it's 13% more than the next one there. And a shortage of skilled network operations personnel is a big problem in a lot of organizations, right? Teams struggle to hire and struggle to retain. We saw this with a number of different industries at the end of the pandemic, where we had a wave of retirement, right? That's starting to happen a little bit more in networking as well. Many teams are struggling to keep pace with existing demands and those with new technologies. And so specifically when we're talking about cloud, we're talking about totally new technologies, or we're moving applications that we used to host internally. So all that institutional knowledge of how that was hosted, all the nooks and crannies we could find issues, has now been shifted to cloud, where we don't have the visibility, and we may not have the expertise to understand how new applications are architected. And so as I talk to customers of ours, I'm seeing more and more evidence of this shortage. At a customer event recently, I was kind of told that they had to shelve an entire SD-WAN project due to layoffs. They lost a number of people that were going to be able to help and run the project, but that network architecture team got smaller, and all of a sudden they didn't have the expertise to actually do the SD-WAN project. right? The second one there is budget, ever present. Don't need to spend too much time on that. And the third one, which is not really a surprise, but the tool sets and the tooling has become an issue. And part of this is because of that cloud issue where you have to have specific tooling to look into the cloud side. You have to have specific tooling to look at the traditional network, the four walls. And then you had to have specific tooling to maybe look outside of your network to the wider area network. And I love this research because it has some real insights into the network operations mindset. So I do want to thank Seamus McGillicuddy over at EMA for these trends. But let me compound on this issue a little bit, right? So if I take those top three, the skilled personnel, the budget, and the tools, and then we look at the same group and look at their priorities, right? The top two initiatives, as Doug alluded to, public cloud, SaaS adoption, right? And because these are top drivers, right, we're suggesting kind of an alignment between the network infrastructure and operations teams with these other teams that may be responsible for the modernization, right? It could be a cloud team. It could even be just a business team, right? One of the other stats that I found here was the last three difficult performance issues were kind of asked about. 40% said cloud, right? For infrastructure as a service, platform, or software as a service. And one of the really interesting thing is one of the quotes that came from network operations people said, we also have people making decisions like deciding to move everyone to Office 365, which means they have to upgrade. They have got to upgrade WAN links. They've got to, retool part of their infrastructure to support the decision that was made, maybe with or without them, right? IT is not always in that discussion when the business makes a move. And so that's probably ringing a bell a little bit of, the business making decisions without looking at the impact on the network and further down the chain, the impact on the user experience because of those changes. And so one click deeper on that, network operations facing new challenges, right? The business is driving the priorities. But in a relatively short time, networks have grown sufficiently more complex, right? Network services are increasingly reliant on distinct technologies, protocols, and vendors that are outside of our networks, right? And so we increase that cloud adoption, modern architecture, software defined, all of that, right? The percentage on this one of alerts that indicate a real problem is falling, right? Which means the number of alerts that we are getting is increasing based on that complexity, that dynamism in dynamic networks outside of our control, which means that fewer than 29% of alerts are actionable, right? So we need to take a look at how we've designed our networks, how we rely on external networks, right? And build a system that allows us to take action. And so we've built up these 5 best practices to discuss. And so without further ado, let's go into the best practices, right? Observability is not just a solution. I do want to make that clear, right? It's a process. It's a process of designing our networks and systems so that they are observable, so that we can see them, so we get visibility, so we don't have blind spots. That's the goal of an observability solution, to then bring that information into one place, contextualize, and give you the ability to take action, right? So we got 5 here. Let's go through them a little bit. Automated discovery and mapping, right? This is really around data collection, aggregation, and normalization, right? We take intelligent workflows and we drive towards root cause analysis, right? That's the whole point. If we have the visibility into our complete solution, our network, then we can make the next steps work, but not without it. So gain cross-domain visibility. This is about isolating different error domains. I'll go into that a little bit more in the future. And then establishing end-to-end coverage between our users and our business critical applications, because oftentimes when tickets come in or complaints or drivers for changes in applications for the business, it's because of user complaints. So we do need to pay attention to those. And so one of the ways that we can do that is to employ proactive validation, right? Not just getting reactive and waiting for issues to alert or waiting for them to impact users, but trying to get ahead of them, right? There are certain ways we can do this. I'll introduce a couple today, right? Monitor end user experience, or user experience specifically. This is really about 3 different components, right? User experience is built up by the app, the network, and the environment the user is sitting in. So if you're looking at my environment, I'm at home. I've got a fiber connection, which is better than most have in a residential setup. But it's different for anyone who's working from home, from an office, who's traveling, right? And IT or anyone, the level one operator that's going to have to look at my ticket needs to understand what my environment looks like and what applications I'm trying to access and what network I'm traversing. And the last one here, harness intuitive, actionable insights and analytics, right? Contextual data, smart filtering, alarm noise reduction, event correlation. We'll get into all of these. So these are our top ones, and I'm going to dive into a little bit deeply, and then we'll go into a demo, show you how some of this shows up in AppNet by Broadcom. So what do we mean by automating discovery, right? Network is a complex place, right? Internal networks are evolving with, software-defined capabilities. External ones are dynamic. They're changing all the time, and we generally don't have good visibility into them if you're using traditional monitoring methods, right? It's no longer viable to have a network diagram that's handed down through the ages to new employees that we update in Visio every once in a while. It's fine for planning. It's fine for creating the network, but it's difficult for production environments that rely on any external networks, right? Let alone cloud or SaaS networks. So discovery and mapping is really about understanding what inputs or what data we can put into our system. And is that a one and done, or is that something that is going to reflect changes that are made in the future? Or do we have to continually come back to this? And so we've got a couple use cases here. And what I'm showing here is DX NetOps and its topology views. So part of the Broadcom network observability solution. But if we start with that internal network, right? We start with the one that we've had for years, right? It's the one that we've historically had the most control over, right? We've had the most visibility into. What's changed is that it's become more difficult as these networks have become more complex and as the number of kind of egress points to external networks has increased, right? It's difficult to cobble all the data together to show the dependencies and show the relationships between our different devices. And so our use case here is, how can I see a unified view of a distributed network being monitored in a single pane? I personally don't love the single pane of glass idea because it's kind of hard to do. And that's an understatement, right? It is difficult to put everything in one. But what we want to do is put enough context around the data that we're seeing so that we can take action, right? So that we can get to that next step. So we need to use pretty advanced tools to kind of show the topology of the network, right? This is not only the discovery, but then understanding the relationships upstream, downstream, and all those components. But it's these connections that are kind of crucial to the observability side. So the second part here is taming that complexity, right? How do I correlate the local area network that I know, the software-defined, connections, the WAN? Do we have SD-WAN on top of that? How do I connect all that visibility so that I can see when it's impacting a user or the enterprise network specifically? So we need a comprehensive view, right? It includes the overlay and the underlay, and that's a component that is fairly specific to SD-WAN and some other components. But the idea is that when we just look at a specific technology, so let's take an SD-WAN provider specifically, if we look at the visibility they provide, it's very good for the tunnel itself, right? It gives you, end-to-end metrics, traffic, throughput, things like that within the tunnel. It doesn't give you any view into the underlay. And so if an underlying network issue is impacting the tunnel, you're just going to see it as a tunnel metric being impacted, but you're not going to understand that it's actually because the tunnel decided, based on the, profiles and the decisions that were made to go over an AT&T network versus a Verizon network. And that's actually where the issue is. And it's, maybe a lagging indicator of when it changes over. Maybe it's a very quick transition, but if a user is impacted in that turnover, in that transition, and it switches, you may not have the historical data to understand that, we were running over AT&T for a few minutes there, and that's why that user got impacted and no one else did, right? So being able to see the overlay and the underlay is a really important piece here. So I want to remind folks here, you can't fully work on network observability without doing this part first, right? Without understanding your local area network, the parts that you have full control and observability into, right? You need to understand the relationships and the dependencies, need to know what's connected, and then you can achieve a little bit more from the internal perspective. Then we have to layer on the external perspective. So in this case, if a switch goes down, we want to get alerted to that. We don't want to get alerted to the thousands of other connections or the hundreds of other connections that are impacted by that switch going down. And so that's where the context and basically the event correlation or alarm noise reduction comes in, is we want to make sure that when we get an alert, when we actually need to take action, we're not sorting through thousands of these. We're sorting through the one that says, hey, this switch went down, which impacted all these downstream events. And so context is really important there. So we've looked at the internal side. Now we need to start mapping the external side, right? And so this is where some of the most exciting parts come from, right? We're looking at what amounts to a trace route, right? It's showing the aggregation here based on the network. So using IaaS numbers from BGP, using the end user environment and IP addresses in our local network, and then looking at cloud application service provider environments, right? So at its heart, yeah, it's traceroute, but by using some continuous monitoring on top of that, we can not only see different paths over time, but we can compile data on how often we're taking each route. We can look at how that route changes, right? We can see hop by hop where traffic is going right as an issue happens, because when we trigger a diagnostic, we're going to have the trace route and the path, the network path that user took at that time. And so that's we'll get back to that in a little bit around diagnostics and kind of running through the entire path. But we're going to look at a few different things today. And one of the things that I think still kind of stymies network engineers is understanding what happens outside of our firewall. And so it can be pretty complicated. It can grow, right? But we want to be able to understand when poor performance hits, what was the actual path? We usually know, if I'm looking at my home environment, there's only a couple hops before I'm on an ISP, right? The connection to this webinar here is my computer connected to, my gateway. That's going out on the fiber line. And then I have no idea where it goes unless I'm using this kind of monitoring where I'm looking at the ISP, the transit provider, and all those different components. So we touched on this as kind of part of the troubleshooting process. We got to isolate where the issue is arising. Like in this case, when we had bad video to start this for Doug, right? It was likely in the ISP. And that's something their team was able to isolate because the rest of their solutions, the rest of their components, the rest of their users in their location were kind of experiencing, either the same or nothing crazy, right? Which means that it comes back to like data versus voice and video traffic being slightly different in how it impacts the network, right? Data might be fine, but then voice and video, because it's a little bit more latency sensitive, might have had the issue. And so here we could isolate it to the ISP, and, one-off event, you might not be able to do anything. But if you have this continuously, that's a trigger to go look for a new ISP, or that's a trigger to go back to the ISP and establish some SLAs, right? There are some options there. So let me switch over to our second one, cross-domain visibility, right? Why is this top our list? Why is this a challenge, right? When issues arise and you get into these war rooms, right? The triage process is very difficult because it becomes a lot of finger pointing, right? Network operations teams need to determine whether or not their network infrastructure is at fault. If it is, then they need to be able to show where they can fix it or go fix it. If not, they have to provide evidence, right? It is guilty until proven innocent when we're talking about war rooms. We need to show where the problem is. And if you have gaps in the visibility or the data, that makes that task impossible. Right? So we need to isolate these issues more efficiently to understand who's at fault, to take action. Or in order to keep IT and network operations credibility high, is be able to point to where the problem is and say, yes, we understand there's a problem, and we can alert people before users are unduly impacted. Okay, so cross-domain visibility is a challenge, and I'll come back to statistics here for one last time, because if we look at the number of tools that network operations teams are using for monitoring and troubleshooting, it's a pretty high number, right? But what I found interesting is between 2022 and 2024, there's a breakpoint. So if you look at the first 5 or 6 here, right, more than 25, 21 to 2025, all the way down to 6 to 10, all of those numbers are falling year over year. When we get to 4 or 5, all of those numbers below are increasing. So there is a sweet spot here, right, where somewhere in the 6 to 10 range or the 5 to 10 range, all of a sudden we need enough tools. We need a few more tools to kind of solve the issues. But really what this is this is an indication that one tool bringing it all together is a little unrealistic unless you're bringing different data sets, like diverse data sets together in one place. You may still need point tools for specific technologies, and that might never change. If you host an application in the cloud, you're going to want to look at the cloud APM or the cloud, CloudWatch type solutions that are providing us insight into, the VMs, the containers, all the kind of components, right? Caching, DNS, all that kind of stuff. But if you're looking at it from the network perspective, you're going to need a totally different tool set. And so those are still pretty diverse, and we still have these different components. But at the same time, there is a sweet spot where you need enough tools to get the visibility and to get the different components. But you don't want too many, because then you're basically siloed and you have to keep switching context to different tools or different solutions every time you isolate one more part of the issue. And so troubleshooting becomes kind of a pain when you're jumping from, dashboard to dashboard or trying to connect it all. So I want to come to this component. I teased it a little bit, right? Typically, we look at something like this for error domains, pretty simplistic diagram, but we're looking here from user to application, right? So with the multi-cloud idea, this is the same, but instead our path is between two cloud providers instead of an office and a user on one side and the cloud on the other. So what remains the same for all kind of contexts when it comes to visibility is we typically have good visibility on one side of the equation, probably less on the far side, even less in the middle, right? That's transit. That's where we lose a lot of the context. And so we want to isolate the error domain when we have an issue to one of these different components. And also when we think about observability, we need visibility into each one of these pieces. And so if we're looking at basically the left side, right, the end user domain, right, this could be an office remote user like myself. In some cases, the offices, you're going to have ownership of the devices, right, wireless access points, firewalls, right. You're going to have visibility into whether those devices are up, down, running well, all those kind of things. In remote offices, you don't, right? A lot of people are going to be on asymmetric residential links from whatever the ISP is in their area, and they're connected via a Wi-Fi gateway or a Wi-Fi router from 5 years ago. Might be on the latest standard, might not be, might be even older. We had some horror stories in the pandemic with people connecting to neighbors' Wi-Fis, coming from the roof or creating a ticket saying I had poor performance, and then coming in and saying, oh, well, I'm wired now when IT actually comes to troubleshoot the issue, but they were wireless on the back deck beforehand when they had the issue. And so understanding kind of what that end user environment looks like and how it changes over time is super important to solving these issues. Once we go into the WAN, right, the second box, the third, and the fourth, right, there we typically have a black box. So typically we're not able to get an SLA for performance or uptime, right? These are very dynamic networks, right? As we pass to the transit and the backbone networks, typically we don't have to worry about speed here, but they're dynamic again, right? Problems can occur at the boundaries where you get into the larger pipes, you get into load balancing, but they can also be a lot more congested. And so finally, on the right side, we have the app infrastructure, right? The application service provider environment, be it cloud, data center, or maybe another office if we're just looking at end-to-end path, right? We have dynamic networks when we're talking about cloud, slightly different, highly variable, right? We also might have control of some component of that. If that is an application we own, we're using infrastructure as a service. But if we're using a SaaS app, we typically won't have any indication of what that is. And we're also probably going to a number of different endpoints over time. And so the application, if I'm going into Slack or Salesforce or Teams in this case, might be a different server entirely than the one I connected to 5 minutes ago. And so when we're looking at these error domains, we're looking at reducing the scope of the problem, identifying where on this path the issue is, and so that we can understand who's responsible for that performance, right? So if we narrow this to an ISP view for a second, right? Isolating the error domain to the ISP, there's a couple things we can do there, right? We can understand the underlying infrastructure. So for in an SD-WAN, we can understand the underlay and the overlay, differences in performance, or maybe differences in routing there, right? Get real-time comparisons across locations. And this is really interesting because we work with a lot of centralized IT teams that often don't know what the ISP is for a ticket. So a ticket comes in with user performance. They have to go find out what the ISP is for that area if it's limited to an ISP problem. When we look at, taking the end user perspective and getting data from that middle mile there, we need to take into account looking at that kind of information and bringing that to the surface, right? Contextualize the rest of the troubleshooting process by giving them the insight to say, oh, I understand that you're, in Boston and you're on Comcast. And so I have a little bit better idea of what's going on here. I have a little bit more kind of connective tissue that I can look at, those kind of relationships and kind of connections that we were talking about earlier. Okay. So I think that that covers a lot of what I want to talk about when it comes to that cross-domain visibility. Is like you have the inside, you have the outside, but that connective tissue of the error domains and kind of mapping that fully out for your users, for your offices, is really what I wanted to talk about. So we have another one here, proactive validation. And this one's a little bit different because when we talk about network performance and experience, validation really involves kind of confirming whether the connectivity, the health, the performance, and the user experience meets our expectations. And another point, when we have global workforces, expectations are going to be different depending on where you are. But being able to proactively validate before, during, and after changes is going to be a huge boon to the network operations team. And so first thing I wanted to bring up is active versus passive testing, right? In that megatrends report that I was talking about earlier, 93% of IT organizations are using or planning to use a synthetic network monitoring tool, okay? Primarily to improve observability of SaaS, public cloud, and cloud infrastructure, right? So when we talk about active, it's referring to sending traffic out over the network, right? Instead of just collecting data, which is the passive side, collecting data that already exists, we're thinking SNMP, BGP data, all important data, right? We do need that because SNMP is going to be great for understanding devices. BGP is going to be good for understanding ISPs and outside kind of influences in the WAN. The active side is going to give us the end user perspective. It's going to be able to test from our offices, test from our cloud environment, right? Test from remote offices. I have, a deployment of AppNeta on my machine here, and it allows me to see what my connectivity is and how it changes over time, what paths I'm taking. And so if IT ever has to work with me, they can go look at that and see exactly what's happening. Right? So active and passive, I just want to introduce the concept. If you're not familiar with it, active, we're sending traffic out over the network in order to monitor it. There are two types of synthetic traffic that I'm referring to here, network and web. And we'll get into that a little bit in the next slide when we talk about TruePath. And so TruePath is AppNeta's proprietary technology. It focuses on a system called packet train dispersion. And what this is it's sending and receiving many kind of short sequences of packets, right? And this is targeting an IP endpoint or targeting another AppNeta device. We have virtual and physical devices. And we're sending these packet trains that have a very specific subset of packets in them and very different types of components in there, all meant to measure the network. So we're able to build a complete set of kind of network statistics very quickly, right? In just seconds, but it focuses on understanding the kind of the end user experience because we're looking at data packets, we're looking at voice packets, we're doing this all super low overhead. This is half of 1% of network traffic out of a device. And so it allows us to do this in production, right, next to the applications that are actually running the business. And so by sending these multiple sequences, right, we can analyze a wide range of different traffic conditions. User might experience, differences in routing, MTU mismatch, right? There are a bunch of different things that pop up. But we use this because you can't use a Flutter, right? The kind of, the high accuracy way to understand what a network is available. You can't use a Flutter as soon as it goes to the ISP, it's going to get blocked, right? If you're using it internally, you can use it, but you can't use it in production. And so we have to use these kind of methods to actively test the network, but also understand what it looks like as we're using it for other things. And so we're able to analyze the network in kind of two specific ways, right? A functional network model and a dysfunctional one, right? Functional implies that, it's normal, it's performing as designed, right? In that case, the measurements that we have represent capacities and the usage of the network. But dysfunctional is outside, right? So the simplest example of that is packet loss, right? Within this train, if we lose 9, 7, and 4, then we've got packet loss, and we can understand the impact of that on the actual end user. If we've got reordering, if we've got out of sequence, if we have shuffling or jitter between them, the distance between them, that all can show up within the model. And so this is what we're using from the active network side. Web, we'll go into in a second, but the website is one that's a little bit more understood in the sense that we're using web synthetics. We're using an engine, Selenium scripting, to actually test for the web synthetics. But when we hear synthetics, we typically think of the web. This is all the network side because it's just as important, right? The highest level question that network operations is often tasked to answer is it an app or is it a network problem? If we can solve that, we need to go one click deeper on either side. If it's an app problem, what's next, right? If it's a network problem, what's next? And so the network problem, I'm going to show a little bit more in the demo. For the app problem, what I can do is I can go into the end user experience. I can look at the application side of it. So, when we're talking about connected experiences for end users, any user, any application, no matter who owns it, right? Network observability tools have to extend beyond the network perimeter, right? To go look at where this application is hosted and understand the impact of that when it slows down, right? Applications rarely go down these days, especially the big ones, right? You think about Microsoft Office 365. If that goes down, it makes news, right? But it does get slow. The question is, what is slow about it? Is it the end user environment? Is it the ISP? Is it transit? Is it the application service provider environment? The cloud itself, right? There's understanding of that. If it's slow, we need to understand where. And so monitoring end user experience is specifically about getting the end user perspective, right? It's not just monitoring the app. It's not just monitoring parts of the network. It's monitoring the chain, the delivery path of that network, of that application to that user. And so when I talked about it earlier, I split it up into a couple different pieces, right? I split it up into the application side, the network side, and then the environment. So the application, just throwing a few things in here, right? We have application timings. We have server and browser breakdowns, which are typical in web synthetics. But then the additional timings of, was there a redirect? Is there a DNS connection issue? Right? TCP connections, SSL, the download of the actual, HTTP file and the SSL file, the CSS files, right? We also have AppDex scores. AppDex people tend to love or hate as far as applications, but it gives you a great baseline for performance, right? It tells you when a user in, Portland, Maine is getting a worse performance than one in Denver, and you can understand how their connections actually go to either a specific single end user server or maybe multiple, and maybe it's just one is better than the other at the time. From the network perspective, when we're addressing performance, we have to talk about metrics, right? Different thresholds but we need to measure at least, capacity, latency, loss, jitter, and then I alluded to it earlier, but the data specific loss and latency and jitter, and the voice specific, right? Because typically when we're doing voice, we have smaller packets so that when you lose them, you don't actually see the impact as much, but the networks reflect different performance for those types of packets. And oftentimes networks are optimized for one or the other, sometimes both, but you'll often see problems with, I can get to the application, I can, download the web page, I can connect, but I'm having audio issues or I'm having video issues because that's more of a latency sensitive application. Right. So real-time apps are harder, right? That's one of the things we saw earlier, right? Teams, Zoom, this platform, right? We know that the data and voice packets behave differently. And so that's why we actually put real voice packets, including the SIP stream, out on the network to understand how the network reacts. And this is how we can kind of get ahead of some of these issues, right? And the environment on the right-hand side, right? Isolating the issue to a local network or an ISP network, right? It allows us to look at all those error domains and isolate where the problem is, right? That becomes the most important part, right? And we can add our internal information. So on the last mile or even the last, few feet when we're talking about an office or a home environment, right? We can look at the Wi-Fi, we can look at the device statistics and understand what's actually happening from a user level. So I wanted to key in on enhanced metrics just a second, just to kind of give you an idea of what we're doing here, right? The total response time is going to be the time between, monitoring begins with, a redirect or a DNS. Essentially, its DNS is usually the first step. Redirect's going to happen before that once we have our IP address. But understanding all these different connections. So understanding where the problem is, right? We've already drilled into app versus network. Okay, it's an application problem. Now we need to drill into all these different components because some of them are going to be ones that network operations has planned, right? If you have a DNS cluster or you're paying for a DNS through someone, then knowing it's a DNS problem allows you to figure out who owns that problem, right? What's the responsibility? Who's the sphere of influence there? If it's TCP or SSL or request, right? That could be an application problem. That could be a server-side problem. That could be, if you own the application, it could be something you could go and work with the application team to fix. If it's a SaaS application, then you can go and contact your representative for the application and open a ticket with them, right? If it's a redirect, that might be something that you can fix if you have that embedded in your system or if it's in theirs. And so there's a bunch of different components here. And I just wanted to put this as kind of an illustration of we have all these timings, right? We can understand these from a web request standpoint, but understanding where the problem is, even within an application, not even talking about physically where as far as the network's concerned, but now logically where within the application allows us to point the finger in some ways, but also understand who can actually fix the problem. Okay. So jumping to our last best practice here, and then we'll kind of pop over to a demo. So how do you get data from, from the data side to insights to actionable insights? And, the easiest answer here is context, right? Put the data you have in context. And sometimes that's just about connecting data to business use cases or business, applications, right? Oftentimes we have data that says, our, switch is overloaded. Okay, why is it overloaded? Do we have an understanding based on the packets of what applications are actually making up the most of that traffic? And we've seen this a number of times where we'll isolate a specific protocol that is just pinged the top of the traffic, right? And we saw this when, years ago when Google released their UDP-based QUIP protocol that was the backbone of Google Drive. And it just popped up one day and, everyone kind of either knew it was coming or didn't, but understanding what that application was and understanding, oh, hey, that actually is connected to the user that's having the problem. The user, VP who just got a new computer is downloading his entire Google Drive onto his computer. Like, yeah, that would make a difference in the bandwidth that it's coming into the business. And so actionable insights is connecting that data stream, that protocol and that throughput of the switch to the user, the application, and the location that it's happening. And so putting it all in context, we can actually answer that question. So I've got a few examples here. I wanted to kind of focus on this because there are hundreds of ways to do this and bringing it all together. But that important piece is the context, the business context to the data. And so one of the examples that I have here is around ISP SLA reporting, right? So it's one example, but it's an interesting one, right? We've talked about error domains and data, but it's that context that kind of makes that actionable. And so in this case, take data loss on a specific network path between me and, a hosting environment on some meeting. And you may think it's a Zoom issues, or you may think that I have issues on my side. But if you have multiple endpoints testing to that same hosting environment, right, we can exonerate the application by saying, hey, the only one that has the problem is me, right? It's one application or one user. Maybe it's a location specific or a user specific problem. And so we can go look at multiple users in the area. We can go look at multiple regions connecting to the same application and build that to see that, oh, yes, we have an issue, but it's only with this site. And so all of these together makes that an actionable insight by able to kind of bring those pieces together. If you take a look at the right-hand side as an example, this is a dashboard where you can show me as a network operations person where to focus my time. And so this is a remote office or remote work violation summary looking at the different ISPs that could be the problem. And so this is, looking at the Windows-based computers, and I'm seeing Consolidated Communications, TELUS, and CenturyLink as the top couple there that I can go look and drill down and see, oh, we're having a real issue with these ISPs on these devices for these users, and we can kind of limit that or connect that up to the tickets that are coming in for that. A more concrete example is going to be over with HCI Healthcare, right? For decades, HCI Healthcare has expanded. They have a pretty diverse network, right? Bunch of different technologies in there. And it got dynamic, it got complex as they relied on more external networks. And so their disconnected kind of network and monitoring was the source of their finger pointing, right? No visibility into some of their more recent deployments. And what that led to was over the course of a year, they had 12 billion events coming into the network observability solution that they had before. And so bringing in Broadcom, we were able to reduce that by 5 nines, right? Getting down to the specific alarms and alerts that actually were causing problems, right? Alarm noise reduction, getting rid of those, no brainer for them because they were able to take that down. If you have 50,000 events per day coming in, like where do you start, right? If thousands of those are critical, where do you start, right? That's going to overwhelm any IT team, right? Any network operations team. And so by using things like alarm noise reduction and contextualizing those issues with the relationships, with the connections of the devices, you can bring that down to a manageable level, right? And so this is a really interesting one because, we often talk about, reduction in mean time to resolution or reduction in alarm noise. And it always goes down to something like 99.9 whatever. And it's because if you're saving, let's say an issue has been persisting for months and you solve it within a few hours because you have better visibility, no matter what, that's going to be a reduction in time that's over 99.9%. And so there's a lot of things we can do here, but it all centers upon getting the visibility into these specific pieces. And so in order to kind of show that, I want to jump over to our demo environment. And I'll start with something that we've already seen, right? And this is kind of a multi-path route visualization that we have. And first thing I can show you is that we're in our AppNeta solution. We have limited the application to Microsoft Office 365, right? We're looking at a 10-minute range, and we're just looking at the high-level network diagram. So this is the dynamic network diagram. You can see, if I open up this, the first thing you're going to see is there's a ton of endpoints on the Microsoft side. Within the last 10 minutes, most of these connections have gone to multiple endpoints or multiple Office environments from the server perspective, right? If I get rid of that, looking at just a couple of these locations, I can see the ISPs involved. So this one goes through Zayo, this one goes through GTT and Cogent, right? And so if I expand this, I can see the hops here from our Las Vegas data center. I can see the hops within GTT, hops within Cogent, and you can see that there aren't a lot of hops in the ISP when you're going from a data center to a cloud environment, right? Those are often optimized. But if I'm going from another environment, so let's say I'm going from this Vancouver environment, let me basically just shorten this. So if I go and just look at this device, right, then I can see very easily what hops were in the LAN, right? I can see our actual ISPs there, or sorry, our IP addresses there. Then I can see where it's going. I can see the dynamism in that network. But I can also dive a little bit deeper, right? It allows me to go in and see the actual link itself. And this is connecting out to Teams. So if I look at this, it's going to show me the current route or the most recent route. I can open up the events and see that there's just a number of route changes happening. I can look at the capacity over time, and this is looking at the utilized versus available capacity on the link, right? We use a bunch of math to actually determine what that looks like, and we can look at what our provision capacity is, so 400 megabits per second there. We can look at jitter and loss. We can look at latency and round trip time. We can then look at the voice-specific metrics, always in purple here, right? Voice loss, voice jitter, and the mean opinion score. Now, these all look pretty good, right? This, again, is going to be the most recent, so it's the last hour. If I go up here and add 8 hours, it's going to crunch some numbers and bring me back a little bit more. So we can see there was actually an outage, a very short one earlier today. We can see if there's anything that happened at the same time. We can see that we've gotten more jitter and loss statistics. We've seen a little spikes there. So nothing major in this one. This is a pretty good connection, right? So maybe we look at this and we say, oh, well, the application or network issue doesn't seem like a network issue. Let's jump into the application, right? So if I go over to web app groups, and this one we're looking at Teams, maybe we're looking at other Microsoft infrastructure. I go to the web app groups and I look at maybe Google, right? And I can see that we're actually getting a lot of failures in our script to Google. And so we spend a lot of time talking about the network, but the application context is important. And when we create these application synthetics, we're actually putting an underlying network synthetic as well. And so we can connect these. But if I clicked in to one of these, what I'm going to get is a little bit of what we talked about earlier. We're going to get the transaction time broken down by milestone. Now, milestone is an ethnetic concept. It's basically we're taking Selenium, which is the web scripting, and we're adding logical transitions, right? When you think about web synthetics, oftentimes the breakpoints are going to be page loads, right? It's when does a new page load versus when does a logical change in the workflow happen, right? With a lot of applications today, we have what we would call microserviced applications where, parts of it are loaded at certain times. And so you might not get a new page when you're changing context. You may actually just need to have a logical change in your workflow. And so I can look at the milestone breakdown. You can see it actually is timing out after 35 seconds. So that's not as easy. I can see the network server browser breakdown. So that gives me some information. But if I go down to the enhanced web metrics, I can see a lot more. I can see about, there is a redirect in this one, right? DNS lookup is 0, so it's cached. Right? TCP connection, no problem. Request wait, download. I can see a lot more information to show that, okay, the application is in pretty good shape here. I can see the actual download of how much and how often. I can look at Apdex and see how that changes over time, right? That's that kind of index score. And then I can look at DNS, right? One of the issues with DNS often is that it takes the fastest response. And so if I want to have multiple servers or if I have multiple backups, I can connect a few of those and see that, oh, I'm actually not getting as good a performance from Quad 8, which is going to be the one that I might want to look into if it's constantly not as fast as the other ones, or if I have a cluster and a good response is hiding a bunch of bad responses, right? I can do that through the application context. So I know I'm jumping around a little bit here, but I want to switch back because we looked quickly at network, we looked quickly at application. But what if we're just trying to get some context of what's going on, right? I want to go up to something like violations by application. These are one of our dashboards. So if I'm network operations, I can use this up as a screen. I can say, okay, let's get a violation summary of what's happening in my sphere of influence. And I can look here and say that generally, okay, SD-WAN, I've got violations within that. I've got violations within Google Cloud Console. I've got some violations on Zoom, right? Darker blue means more violations within the time period. So I can click into any of these and I could look at the actual paths that make this up. You can see that some of the violation durations are pretty long, and these are 2 quad 8. So that's actually testing to that DNS service that we looked at earlier. And so I could spend time actually going and looking into this, right? What's interesting with a lot of these is that I can group and filter these however I want. We've got a couple, different ways to, show these up as dashboards, but I could also look this as a map. I could look at violations across these different components, right? I could look at an SD-WAN underlay versus overlay, right? And I could understand, okay, the overlay is having more problems than the underlay. So that shouldn't happen because the overlay is the part that should be taking the best path. So let me switch over to usage to show our last component, cursor the demo over there. So the last component is one that I haven't talked about too much right now, but it's something where if you want to look at the applications that are in use in an office environment and understand what's actually taking up your bandwidth, this is another component that allows us to dive, not between app and network from the macro sense, but from the micro sense and actually look at the packet level. And so to understand when other apps are running on the network that may be impacting experience. And now you can see this is a very small example. It's from actually a remote user. And so you can see YouTube TV is actually a pretty high one. We might not want that within our office environments. But if I click on Denver, I can jump in to a more specific view of the top applications and the packets that are showing up in this. So you can see that within this environment, I actually have the most amount of packets and volume here is actually OneDrive. The next one is Quick, which is that Google Drive protocol. We've then got generic UDP. We've got some AppNetto monitoring. We've got a number of AppNetto devices at this user's house to actually test and run this demo environment. And then we can see Microsoft Office 365. I can go in and look at all the hosts we're connecting to. So from a micro level, when you need the packets and the actual packet captures, we can schedule packet captures from our devices. That's going to be another level of insight that we can have for offices and for users. And so what this is doing is it's taking the packets and it's doing a 100% look at the packet data to understand basically what endpoints are being targeted, and then using that to run through an engine that actually identifies over 2,000 web applications, and you can do custom ones as well, to isolate and kind of map this out to understand what our applications look like. And that's using a deep packet inspection engine. That's kind of the 3 main components that I would point to as far as having experience for the web, delivery for the network, and then usage for the actual packet. So those are kind of the main components that I wanted to talk about. And that all goes back to kind of service the fact that we have different ways to view all of these systems. And so when we automate the discovery and the mapping, right, that first best practice, we need to collect all this data. Then we look at cross-domain visibility, the internal and the external. We look at proactive validation. That's with that active testing for both web and network synthetics. We monitor the end user experience, and then we contextualize. And so those are the main components that I wanted to go through today. And so with that, I'll pass it back to Doug and see if we have any questions.
Great. Well, thanks for that, Alec. I was paying extra careful attention. I won't get into the whole, I'll ask straight up. ISP SLAs, which seem relevant to me at the moment. How does the solution, can the solution enforce that? How does it deal with that sort of relationship?
Yeah, and what's funny is that is a tough one, right? It is tough to prove to an ISP that it's their fault, but it's the data, right? The data, by providing the data, showing exactly what IP addresses are involved, allows them to see exactly where the problem is. And so oftentimes you may not get hey, we're sorry, but you might get it fixed just by providing enough data.
All right. I like where that's headed. I want to make sure I understand the difference between active monitoring and synthetic monitoring. I know you covered it, but if you wouldn't mind just touching that briefly again.
whenever we hear synthetic in kind of the network world and in kind of our space in tech, we typically think of just the web side. And so one of the things that I've been fighting over the past few years, and really a part of my career at AppNeta, is making sure that people understand synthetic monitoring is just the idea of creating traffic in order to monitor a network. And it comes in two forms. There's network synthetics, where we're actually sending test packets out, and there's web synthetics, where we're looking at kind of throwing a workflow together to automate a browser, right? To automate a client and make it look like we're actually browsing a website, right? We need to do the same thing for the network side. And so when I say synthetic, I am thinking people are generally thinking of web, not network. But when I say active monitoring, I want to take all of those into account. So active monitoring is any type of technology, both of those type of synthetics and a few more, that actually sends traffic in order to monitor the networks. And so that's sort of a slight difference that I wanted to make.
Yeah, well, with regard to active monitoring, I think that's, for me anyway, one of the things that I want folks to take away from is how to start preparing for that. I mean, what should people be thinking about as they're beginning a conversation, hopefully with you and AppNeta, with regard to active monitoring?
Yeah, I mean, it's really about being honest of where your blind spots are, right? If you don't have visibility into cloud environments, then we need to look at what the dependencies are there. Are you using specific SaaS apps? Do you have your own environments there? Where's the blind spot on the cloud side when you're going into a troubleshooting or a triage workflow? Where do you not have data? I think most people don't have data in the ISP, in the transit environments. A lot don't have it in the cloud environment. And so making sure that we're kind of honest about where those blind spots are allows us to figure out which technologies are best when it comes to providing that visibility and driving into an observability solution.
And so, we always encourage everybody who watches something that we put in our spotlight to engage. There's honestly no better way to understand what is happening in your particular environment than to talk directly to the folks that have the experience, that can overlay some relevant projects that they've done that may be similar, that can really give you the solution perspective that's unique to you, because everybody obviously is dealing with a unique situation. I'm curious how long that typically takes. I mean, what can somebody expect as they reach out? How does the process work, and where can they start to potentially test value?
Yeah, absolutely. So the process can depend. I mean, I think there are different components to this. AppNeta is actually very quick. Deployment and install can be done in a few days, a few weeks, depending on what you need. For the whole solution and understanding kind of what each individual organization needs, it usually is a process where we take a few months to work with the customer to fully map it out and plan it out and do it. But there are ways to do, proof of value or proof of concept phases where we understand, putting a small component of the system on and then scaling it up afterwards. And so really the first thing is to reach out and we can talk about exactly what the needs are, right? Where the pain points are today, and then how Broadcom can help.
This was great, and truth of the matter is I'm kind of glad we were experiencing a little bit of an issue, because I think it really points out just how much we rely on things that we take for granted, and network connectivity and packets and all that is happening both inside our own spaces, but what happens once it's outside of our control. I think we just take for granted, and it's incredibly important to have solutions that can monitor and help alleviate as problems arise. So, Alec, thanks very much for this presentation today. It was great. I loved it, and we obviously love covering everything that Broadcom's doing, and we'll be tracking more of that at Solutions Review. Best of luck for the rest of the year, and we look forward to talking to you again soon.
Great. Thanks, Doug.
Well, there you have it. Another solution in our spotlight. We want to thank Broadcom and Alec for that presentation, and we appreciate your attendance as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.
If your business would like to be featured in a future event, contact us today.